Hi guys, welcome back to my YouTube channel. This is Tanushree. In this video, I had taken the topic that is chemical bonding and molecular structure. Okay, in this video, we are going to study a very interesting topic that is chemical bonding, which is very basic for every atoms which combines together to form some bond. Okay, in that we are going to study ionic and covalent bond, and before that we have to know the valence electrons of their particular atom of a molecule. So in that we are going to going through the class 12 syllabus. Okay, so it is very important for a class 12 students, so please do subscribe to my YouTube channel and click on the bell button icon that will notify you for my upcoming videos. So let's move on to the video. So here, octet rule: atoms of a different elements, okay, atoms of a different elements or a molecule taking part in a chemical combination in order to complete their octet or to attain the noble gas configuration. If we consider any atom, okay, if there is a uh, atom which contains only 7 electrons in their outermost shell, so there will be a deficiency of 1 electron. Then what will happens, the another atom having a 9 electron, they should be share the electron, one of the electron to the atom, and make the both atoms are becomes noble gas configuration, octet configuration. So this is what the octet rule says. The name itself says that. So there will be a sharing of an electrons between the atoms by forming a chemical bond to have a both are in octet form. This is what the rule. Okay, so valence electron, as I told, it is outermost shelled electron which take part in a chemical combination. And also atoms having 8 electrons in their outermost shell are stable and chemically inert. Okay, so they can acquire and electrons in outermost shell by two ways, okay, by losing or by sharing an electrons. Okay. Next, facts stated by Kosil in a relation to chemical bonding. So what are the facts by Kosil in the relation of chemical bonding? He said, in the periodic table, the highly electronegative halogens, okay, we know the halogens, right? Iodine, fluorine, bromine, chlorine, iodine. So and they're highly electropositive alkali metals, and they are separated by the noble gases. So these are highly electropositive electronegative halogens. Okay, these are all highly electropositive alkyl metals can be separated by the noble gases. So formation of an anion and a cation by the halogens and alkali metals are formed by gain of an electron and a lose of an electron respectively. As I told that, formation of an anion or a cation by the halogen and alkali metals, there will be a formation of an anion and cation by the halogen and alkali metals that are formed by gaining the electron or losing loss of the electron. So both negative and positive ions acquire the noble gas configuration, as I told in a octet rule. Okay, the negative and the positive ions are stabilized by the electrostatic attraction. Okay, electrostatic attraction. So this is what the some basic definitions and the facts which are given by the Kossel in the relation of chemical bonding, and some other modes of chemical combination we are going to do. Okay, so by the transfer of an electron, so the mode of chemical combination is by transfer of an electron and by sharing of an electrons. Okay, and the coordinate bonds. Okay, the chemical bond which formed by the complete transfer of one or more electrons from one atom to another, it is termed as the electrovalent bond or a ionic bond. So that ionic bond which is formed when one or more electrons that are from a valence shell of an atom, okay, from a valence shell of an atom that are completely transferred to the valence shell of another atom. So let us consider a atom A and atom B. Okay, here what happens, by forming by forming an ionic bond, what happens when one or more electrons that are from valence shell of an atom A, okay, that should be completely transferred. If it completely transferred to the valence shell of atom B, okay, then what happens, there will be a formation of an ionic bond or a electrovalent bond. Then by sharing of electrons, so the bond which is formed by the equal sharing of electrons between one or two atoms, it is called as covalent bond. In this bond, the electrons are contributed by both. Okay, so the compounds which containing a bond are called as ionic or a electron component, which can be said in the ionic bond. Okay, so what happens by sharing of an electrons? I had told in the octet rule. So I had given the example, that is atom A and atom B. Atom A, which consisting of a 7 electrons in the outermost shell, whereas atom B consisting of a 9 electrons in their outermost shell. So what he atom B have to do? So he have to share the one of its outermost electron to the A by forming a covalent bond. So there will be a sharing of electrons between those atoms A and B. Okay, so by this the modes of chemical combination also occurs. So that type of the sharing of electrons is called as a covalent bond. Okay, next, coordinate bond. When the electrons are contributed by one atom and shared by both, the bond is formed, and it is known as dative bond or a coordinate bond. So mutual helpfulness between those two, A and B. So they will mutually face the problem of an octet noble gas. So we have to take an example to get better knowledge about that coordination bond. Okay, these were the three modes of a chemical combination. By the transfer of electrons, it forms an ionic or a electrovalent bond. By sharing of electron, it forms an covalent bond. By coordination bond means mutually they are helpful to each other. So this is what the three modes of the chemical combination. Next, ionic or electrovalent bond. So we are going in depth in that. Okay, this is formed by complete transfer, as I told, that complete transfer of electrons from one atom to another. Generally, it is formed between metals and non-metals. Okay, it is generally forms between metal A and non-metal B. Okay, we can say that it is the electrostatic force of attraction which holds the oppositely charged ions together. Okay, so it is an there will be a chances of an electrostatic force of attraction between the metal A atom and the non-metal B atom. So then only the ionic electrovalent bond is formed, okay, which holds the oppositely charged ions together. The compounds which is formed by ionic or electrovalent bond is called as electrovalent compounds. So the formation of an ionic or electrovalent bond of a whole compound, okay, A and B, which are connected with their ionic bond, okay, the metal and non-metal which are connected with connected to form a bond by the electrostatic force of attraction. Okay, then that compound is said to be as a electrovalent compounds. So example, NaCl is an electrovalent compound. So Na, it is a metal. Okay, Cl is a non-metal. Okay, by this there will be forms an ionic bond in between sodium and chloride. Okay, so this is a best example for the electrovalent compound. Here, here I given the reaction that I told. You can go through that. So here ionization enthalpy means the energy which is required to remove the electron from the outermost shell of an isolated gaseous atom, okay, to give the atom, okay, to convert it into an cation. Okay, so that is what the ionization enthalpy define. Okay, the amount of energy that is required to remove an electron from outermost shell of an isolated gaseous atom to convert it into an cation. Okay, so then lesser the ionization enthalpy, what happens? There will be easier will be a formation of the cations. Okay, if there is energy, so if there is no energy or a less energy, then what happens? The ionic bond formation will be better. Okay, will be done. Okay, so and have a greater chance to form an ionic bond. Due to this reason, alkali metals have more tendency to form an ionic bond. For example, I had given the best example here. In the formation of an sodium, okay, Na plus ion, okay, while in case of a magnesium, okay, here what happens? The ionization enthalpy in a sodium, what it is, 496 kJ per mole. In case of magnesium, what is 743 kg per mole. So that's why the formation here, what happens is the energy and ionization enthalpy of the sodium is less. Okay, magnesium is high, more. Okay, that's why the formation of the positive ion for a sodium is easier than that of the magnesium. Okay, therefore we can conclude that lower the ionization enthalpy, greater the chances of the ionic bond formation. So this is one of the fact which affect the formation of the ionic bond. Okay, so second one, it is electron gain enthalpy. Electron gain enthalpy, it defines as the energy which is released when an isolated gaseous atom takes up an electron. So ionization enthalpy means what? The energy which is required to remove the outermost electron of the isolated gaseous atom, right? So here electron gain enthalpy means what? The energy which is the amount of energy which is used to takes the electron to form an anion of a isolated gaseous atom. So the greater the negative electron gain enthalpy, it is easier will be the formation of the anion. Okay, consequently, the probability of the formation of the ionic bond is increases. So what happens? There will be electrons. What happens? The atoms of a gaseous atom, isolated gaseous atom, starts to accept the electrons by energy. Okay, some amount of energy it will accept the electron by the energy to form an anion, right? So the negative electron gain enthalpy greater, what happens? There will be a formation of an anion. So consequently, what happens? The probability of the formation of the ionic bond will be increases. Example, halogens possesses high electron affinity, so the formation of an anion is very common in halogens. Next, lattice energy or enthalpy. So this is one of the factor which affects the formation of the ionic bond. Okay, it is defined as the amount of energy which is required to separate the 1 mole of ionic compound into a separate oppositely charged ions. So this is one other fact which affects the ionic bond. So lattice energy of an ionic compound depends upon the sum of the factors. So size of the ions and charge of the ions. So these are two factors which is affected by the uh, anionic compounds. Okay, so it depends on the size of the ions and the charge of the ions. Size means it's smaller the size, greater will be the lattice energy. Okay, it's greater the magnitude or a charge. Okay, magnitude of a charge, then the greater will be the interioric attraction, and hence higher the lattice energy. This is two factor which is going to be very important. In that, physical state, melting and a boiling point, solubility, electrical conductivity, and ionic reactions. So they generally exist as a crystalline solids. Physical state, which is exist as a crystalline solids and known as a crystal lattice. So physically means what? Physically means which appears as it is. Okay, and ionic compounds do not exist as a single molecule like other gaseous molecule, like example H2N2O2 Cl2, like that. So melting and boiling point means since ionic compounds containing high interioric force attraction between them, okay, they generally have a high melting and boiling points. Solubility, they are soluble in a polar solvent such as water but do not dissolve in organic solvents like benzene and chlorine tetrachloride, sorry, carbon tetrachloride. Okay, then electrical conductivity, they conduct electricity. Okay, electrical conductivity means they itself it says that it will conduct the electricity, and in a solid state there are poor conductors of electricity, but in a molten state or when dissolved in water. Okay. Ionic reactions, ionic compound produces ions in a solution which gives a very fast reaction with oppositely charged ions. So these are the important general characteristics of the ionic compounds, which is depends on the physical state, melting and boiling point, solubility, electrical conductivity, if it conduct electricity or not, and ionic reactions between the two atoms. Okay, this is what the general characteristics. So next, covalent bond, Lewis-Langmuir concept. In that concept, we are going to study how the covalent bond will be formed between the two atoms. Okay, here I taken the hydrogen and oxygen atom, and how the water molecule will be formed. When the bond is formed between the two or more atoms, by mutual contribution or mutual sharing of an electrons. It is known as the covalent bond, as I told, okay, in a previous slide. If the combining atoms are same, the covalent molecule is known as the homoatomic. If they are different, they are known as heteroatomic. So combining of atoms, if the uh, molecule, okay, which are same, covalently same, then it is called as homoatomic. If they are different, then it is called as heteroatomic molecule. So here the formation of an hydrogen molecule. So we call H2 H2. How the H2 will be formed? H plus H gives rise to H2. Okay, sharing the electrons between the hydrogen, one of hydrogen atom and another hydrogen atom. So hydrogen containing one electron in the outermost shell and another, it also same. Okay, there will be equal sharing between this and this. So the sharing of electron which forms an covalent bond. Okay, then formation of an oxygen bond, same as it is. Oxygen which contains the 6 electrons in the outermost shell. Okay, another oxygen atom in the same position, so they will share the 2 electrons of this atom to the 2 electrons of this, equal sharing between these two atoms to form an covalent bond. Okay, formation of H2O molecule. Here H2 means 2 H atoms and one O atom. So there will be a one outermost electron in the hydrogen and two six six sorry 6 electrons in the outermost electron atom of an oxygen. What happens? Oxygen shares 2 of electron with the hydrogen. Okay, hydrogen shares it one of the electrons with the oxygen, and here we can see hydrogen which is sharing a one electron which is from hydrogen and another electron from the oxygen. Here one electron from the hydrogen and one electron from the oxygen. So this is what the covalent bond formed between the hydrogen and oxygen atom to forming an water molecule. Next, the formation of an ammonia. Ammonia. Here one nitrogen, okay, two hydrogen atoms. Here nitrogen containing 3, okay, nitrogen containing 5 electrons in their outermost subshell. Okay, it will be shared with the hydrogen, right? Here it will be shared with the hydrogen, and then here we can see that 3 the nitrogen which is bonded to the 3 hydrogen atoms. Here what happens, one electron it is from the hydrogen, and here one electron from the nitrogen. So here one electron is shared from hydrogen to nitrogen, and here one electron which is shared by the nitrogen. So same as it is, one electron which is shared by the hydrogen and one electron which is shared by the nitrogen. So how many electrons are present in the nitrogen outermost shell? That will be 5. Okay, so remaining lone pairs are as it is remain. So this is what the covalent bond which is formed between the nitrogen and hydrogen to forming an ammonia. Okay, this is what the formation of the some covalent bonds: hydrogen, oxygen, water molecule, and ammonia molecule. So, Lewis symbol of an atom, which is represented by the chemical symbols of for the atom, surrounded by the number of dots corresponding to the number of valence electron. So, how many valence electrons are present in the each atom, that will be shown in the dot. Okay, in their head of the atom, we are going to show the dot. Okay, so this is what the important steps which are going to be helpful for the drawing Lewis dot structure. Here we can see that here hydrogen, the molecule here, hydrogen and Br we are taken, that is one electron which is shared by the hydrogen and another one electron which is shared by the Br. Okay, so same as it is here also. So here the dot means what it represents, it is the valence electron outermost shell of an atom. So this is what the dot, Lewis dot product or a structure we are going to be represented as like this. Okay, hydrogen which containing only one valence electron in the outermost shell. So sulfur which containing the 6 electron in their outermost shell. Okay, then nitrogen which containing the 5 outermost electron in their uh, valence electrons in their outermost shell. So this is what the dot structure for a nitrogen, hydrogen, sulfur, bromine. So I hope this video is helpful for you. So in my next part, I'm going to explain the some Lewis acid and base concepts. So please do like, share, and comment on this video. Thank you.